Record.
Hey guys, so we're gonna go over Q3 for the discussion and worksheet regular edition. This is a algorithm design question, so it's very word heavy, very concept heavy. So let's get right into it. It's asking us, your airline company has been contracted to fly a large shipment of honey from Huntersville to the 61 bees in Opes City. However, the airplane doesn't have enough fuel capacity to fly directly to Opes City, so it will stop at least one of N airports along the way to refuel. Refueling takes an hour, and if the airport is one of K less than N airports, your airplane will be grounded for 6 hours due to curfews. Refueling is included in the 6 hours. The 61 bees want their honey as soon as possible, so please design an algorithm to find the route that will allow your airplane to reach Opes City in the least amount of hours. And we have a couple hints to consider that's going to help us really grasp the algorithm that we're creating. Think of the N airports as a graph, where the paths between them are edges of weight equivalent to the number of hours it takes to fly from airport A to airport B. You may assume that the amount of time it takes to fly from A to B is equal to the amount of time it takes to fly from B to A. So let's break this down. First of all, it's telling us that we want to look at this as a graph. And graphs have two main components. Graphs have nodes and graphs have edges. So what are each of these going to represent? Well, the nodes are going to be each of the N airports along the way. The edges, as it says in the hints, are going to be equivalent to the weight of the number of hours it takes. So it's going to be hours it takes from each airport. So, or I should say from each nodes connected, from the nodes. Another key component the hint is saying is you may assume the amount of time it takes to fly from A to B is equal to B to A. That's basically telling us that the route doesn't have a specific direction because you can go from A to B or you can go from B to A. So that is telling us this is going to be an undirected graph. So now that we have our graph, what kind of algorithm do you think we could run? Well, because this is asking us to find the algorithm with the least amount of hours from point A to point B, we are actually going to be using the shortest paths tree algo. Because what is this going to do? It's going to tell us the shortest paths. A key component to this problem is the fact that we don't have enough fuel. We have to make at least one stop to refuel. The tricky part about this is some of these airports, these K airports, will have our plane grounded for 6 additional hours because of the curfew. So we actually have to adjust the graphs to represent K. So the big question is, how do we do this? There's actually a bunch of different ways to do it. I'm going to be going over like 3 of them, but there are multiple solutions to this issue. The first possible way to adjust to actually show K airports with those 6 extra hours is we could increase the edge weights of or we can increase the edge weights. I don't know how to spell associating. How to spell? I think it's with an S. Associating with the refuel and grounding times. We could basically think about, because this is an undirected graph, we could basically think about this as 2 different directed graphs and increase the edge based off the node that it's pointing to that has that additional 6 hours. So directed is 2 undirected, node it points to, adjust it to show what K is. The second potential solution is we could add the weights of the nodes themselves. So this kind of creates 2 things to consider as we're traversing. We have to consider the edge weight and the node weight. So if we're considering both of these things, this kind of looks similar to the A-star algorithm that we've learned. The third way we could incorporate the K representation is we could split the nodes where we have two nodes connected, and these two nodes connected have an edge weight. Wow, I can't type or write. They'll have an edge weight equal to the refuel and grounding time. So like I said, these are just a couple solutions to represent K. The main idea is we want to adjust the graph because we want to find the shortest path. Some of these airports are going to have an additional 6 hours, and we want to represent them in the graph. So when we traverse it, we minimize the stops and the hours allotted to actually get to our destination. So because we have our graph set up, we could actually run our algorithm like Dijkstra's, where we start at the node corresponding to Huntersville, and we won't stop the algorithm until we get to the node corresponding to Opus City, and until it is popped off the fringe. The reason we wait for it to pop off the fringe is because the distance to value of Opus City will be the minimum time or the shortest distance. Once we get there, we could backtrack from Opus City to Huntersville, and that will give us the shortest path. So this is kind of how you approach an algorithm design question. You consider all possible components, you create the graphs with the nodes and edges, and you adjust it based off whatever other given things that might be a little tricky or that might affect the shortest path possible.